Hello, my name is Schneider, and I want to present you the PhD planning and schedule of the thesis Definition and Simulation Framework for Positive Energy Districts. My supervisors are Joao Pavao and Manfred Tragner. The motivation of my thesis is rooted in the concept of positive energy districts that play a key role as decentralized micro power cells with flexible demand and dispatch in future decarbonized energy systems. They rely on three pillars: energy efficiency to reduce the amount of energy required in a given district, renewable on-site energy production with photovoltaics and other sources of renewables, and increasingly importantly, energy flexibility to support the surrounding grid and increase the amount of renewables in the system. However promising, positive energy districts still have key problems in quantification aspects, being that the assessment frameworks that are being used in various positive energy districts are incomparable because they're mainly focused on feasibility in their relative local and national context. Secondly, delivering HVAC, e-mobility, plug load, sometimes even embodied energy with on-site renewables and minimal grid extraction requires dynamic energy system modeling to account for the flexible operations that the positive energy districts need to carry out. This is almost infeasible with most current dynamic models, both on thermal and an electric side, especially in the early planning phases of districts where system design decisions have the highest impact and are most crucial. The objectives for my thesis are therefore to first develop a theoretical framework for positive energy district definition context factors that take into account the local potentials and make the PED assessment framework internationally comparable. Secondly, I want to develop a energy flexible positive energy district simulation and assessment model with which I can conduct analysis of various positive energy districts and their performance. Third, I want to apply this developed simulation model to a number of European test cases, positive energy districts, and use it to optimize for a number of system objectives, most prominently greenhouse gas emissions. Fourth and finally, I want to identify feasible context factor operationalizations or localizations of the positive energy district definitions that is in line with system objectives such as the achievement of our climate goals in Austria and in the European Union. So ultimately, the thesis aims to facilitate the quantitative connection of positive energy districts to the surrounding embedded energy systems and their future requirements for a carbon-free society. My thesis is structured in 5 tasks. First, literature research, where I focus on positive energy district definitions, thermal and electric district simulation models and frameworks, quantification of energy flexibility, and carbon intensity and residual loads of future energy systems. The second task, I want to go into theoretical framework, formalize the idea of context factors for a positive energy district definition. I also want to develop 3 concrete examples of such implementations of context factors, namely density, mobility, and climate. The third task of my thesis is the actual development and the testing of the energy flexible simulation model and the assessment model, for which I have already developed a prototype, but will further need further refinement in terms of a Python simulation model. The fourth task is the application optimization, where I want to apply the model to a number of European test cases from our research projects, conduct multi-parameter optimization with the objectives of greenhouse gas emission reduction or minimization of greenhouse gas emissions over the life cycle, as well as primary energy delivered and grid support indicators. Finally, in the fifth task, I want to focus on the operationalization of my work, where I develop scenarios for national context factors, density, mobility, and embodied energy, as showcased on the right here, and links to international certification efforts. And finally, since I'm already engaged in the UTAD definition alignment task force in the European context, I also want to focus on dissemination and feedback from the stakeholders to strengthen the discussion and usefulness of my results. Here you can see the schedule with the 5 tasks and a couple of review papers bound to be delivered by the end of 2021 or beginning of 2022. The collaborating institutions is, apart from the University Tras de Montes and Alduro, the University of Applied Sciences in Vienna. For the curricular plan, I chose these 4 options, and these are my references so far, and thank you for your attention.